Yo, 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 yo! It's your boy Mr. G coming at you live from DePoli, talking about rewriting percent expressions today. And we're going to focus really on the percentage of change, the percentage increase and decrease, but the main focus today is what expression we can write from the scenario, from the problem. So let's get after it. So first we have markup and markdown. Those are terms that we talked about in the 5.1 video, where when we're increasing by a certain percent, that's a markup, and if we're decreasing by a certain percent, that's a markdown. Examples of markdowns is when something goes on sale. If we have a big sale, it'll say 25% off of everything in the store, something along those lines. That is a markdown. That's when prices are decreasing. A markup is when we increase something by a certain percentage. Sales tax is a markup. Okay, all right. So we're going to write two different expressions for this. And we'll show you the benefits, and some people can prefer to use one way or the other, so we'll see which way you like, and then you can stick to that. But I do want you to know, I do want you to be aware, and I do want you to know both ways of how to write percentage markups and markdown problems, expressions. So to make a profit, stores mark up their prices on items that they sell. That's how anyone makes money. So when they buy a skateboard, they buy it for S dollars, and then they mark it up by 42% so that they can make money. That 42% is the amount of money that they actually make. That's the profit. So originally, a manager bought a skateboard for $35 and $56. They marked it up 42%. We want to know the new price. Now, there are two ways to do this. So we can take the price of the skateboard. The manager pays the original price of the skateboard. And what we can do is they're marking it up. That means I'm adding whatever that markup is. Okay, so I'll put markup right here. Well, we know what the markup was. So they take the original, add it to the markup, add the markup to it. Well, the markup to my original cost of S dollars, the markup was 42%. So really, I'm taking 42% of the original price. And when we do 42% of a number, we're actually multiplying those two values by each other. So we take our original cost, we're adding whatever that markup is. That markup was 42%, so that's 42% of whatever the original cost was. So now we can replace in that 35. So if my original cost was $35, the manager is selling it for $35 plus whatever that 42% markup was. Well, for 42% markup, I actually need to change the 42% into a decimal. So that's 42 or 0.42 times whatever that original price is. Well, the original price was 35. This 0.42 times 35, this is 42% of 35. This will tell me what the markup was. And then I have to add that to the original cost to know what the new price is, the final price is. So what I need to do is I need to actually do 0.42 times 35. Now, I'm working it out in a calculator, and I get $14.70. So what they did is they paid $35 for that skateboard, but now they marked it up by $14.70. By marking it up $14.70, they now are able to make that much profit. So the new price, that means they have to be able to sell it for $49.70. And that's my final retail price. They are applying a 42% markup to the $35 original. 42% times 35 is $14.70. So that's how much they're marking it up by, making a new cost of $49.70. That's one way to figure this out. Another way to figure this out, and I'll do this one in blue over here. Another way to figure this out is by taking the 42% markup and just multiplying by the original value and adding that 42% markup to the original 100%. So here's what I mean by that. If you're marking something up 42%, the original cost is equivalent to 100% of the cost. So the original cost 35, that is equivalent to 100%. So if I actually want to mark it up by 42%, that means I'm really charging them 142% of the original cost. The original cost, 100%, is 35. But if I mark it up 42%, I'm adding another 42% of the cost. So I'm actually marking it up and I'm paying a total of 142% of the original cost by marking it up 42. So if it's a markup, for markup, we add 100% to the markup. So if it's a markup, we add 100% to the markup, and then that's my new percentage that I multiply by. And it's actually just one quick multiplication problem. So if I need to do whatever 142% of 35 is, I'm really doing 1.42 times 35. And this is going to tell me what my new cost is. This is already adding the original 35. This is 100% right here, and I'm adding the 42%. This is just doing it all at once. And so what I did is, the reason why I got the 1.42 is if I'm doing 142% to convert it to a decimal, move it over twice, there's where my decimal goes. So 35 times 1.42 is $49.70. It gives me my new cost without doing any addition and subtraction, because it's just it's taking the 100% of the 35, adding the 42% of the 35, and that's why I'm getting the 142%. Okay, so now what I want you guys to do is just write the two expressions for the $56. So just write the two expressions for the $56. Write an expression that looks like this for the $52, and then an expression that looks like this for the $56 for the $56 skateboard. So we figured out the new price of the $35 skateboard is $49.70 in the stores. I want you to do the same thing for the $56 skateboard, and it should be fairly similar. And then once you do that, go ahead and solve it. Okay, so for the $56 one, we have my original cost of 56 bucks. We're adding 42% of that, so my markup is 42% times whatever times 56. That's going to give me my 42% of 56. This is going to tell me how much I'm marking it up by. That's one way to do this. The other expression is, because it's a 42% markup, I know it's 142% times whatever 56 is. Now I could actually work it out and multiply whichever one I want to do. If you want to do the 1.42 times 56, that works, and that's going to give you $79. You can just multiply this, and it's going to give you your final cost right away of $79.52. Now, had we done it this way, 42% of 56 is $23.52. And then, so what we figured out was what 42% of 56 is. So 23 bucks 52 cents. Now when I add those up, I get $79.52 as my new retail price. Okay. The process is the exact same for discounts or mark it down. It's the exact same. The only difference is now I am changing my addition sign to a subtraction sign, and I'm also changing my percentage. So now we're discounting 20% off. So my original cost was $16, so something cost $16. It is now 20% off. So we're going to subtract whatever 20% is of that original cost. 20% is also just 0.2. Move my decimal over once, twice. Another way to write this expression, though, is if 16% is 100% of the cost, but I'm subtracting 20%. I'm taking 20% off, so that's really minus 20%. So that means we're only paying 80% of the whole price. So 80% times 16, which is really just 0.8 times 16, is also going to give me my final answer. So these are my two possible expressions. 0.8 times 16, or 16 minus 0.2 times 16. This is my original cost of $16. Take away, I'm subtracting whatever 20% is. That's the 20% off. Or, because it's 20% off, I'm really only paying 80% of the total price. And then I can multiply these and figure it out. So this is really 16 minus $3.20, because 0.2 times 16 is $3.20. And when I actually do that subtraction, I'll get $12.80 as my new price. Had I multiplied 0.8 by 16, I would have also gotten $12.80. So that's my new price no matter what. So again, go ahead and pause, and then do the same thing for the $23 item, right? The two different expressions, and then go ahead and then solve once you have your two expressions. Okay, so our first one, our original cost was $23. It's 20% off, so that's minus 20% of $23. That's one expression. 20% of $23 is $4.60. So then now I can do a quick subtraction to get my new price of $18.40. There's the new sale price because we took away the $4.60 that was off, because that is what 20% of 23 is. The other expression that we should have written down was we're taking our original cost and we're multiplying by how much total we're paying. Well, we're paying only 80% of the original cost because it's 20% off. 100% minus 20% is 80%. That would also get you $18.40. All right. Now, just things to remember. I would jot down the original formula we had, so we can do x plus or minus the percentage times that original cost again. So this x represents our original cost. That's one way. And we know x is our original cost. So that was one expression we wrote. Another way we wrote our expression, I'll do this in a different color here, was we also did 100% plus or minus, depending if it was a markup or a markdown, our new percentage, and then we multiplied that number by our original cost. So we multiplied this value, all of this, by our original cost. And again, x is our original. And I'm really sorry for my bad handwriting. I'm struggling with this this device here. Okay, well, that's all I got for you guys. So two different ways to do it. We want to learn how to write both expressions, but then eventually once you solve, you can just pick one. So hope this video helped. Thanks for watching. Gradius out.